In today's lesson, we're going to continue our trigonometry unit, and we're going to introduce two more ratios. So the last lesson, you learned the tangent ratio. So given an angle, we defined the tangent ratio as the side opposite as compared to the side adjacent. So the tangent of this angle equals the opposite as compared to adjacent. So we are now going to learn two different ratios. We are going to learn the sine ratio and the cosine ratio. So the sine of an angle, right? You always have to put an angle next to the ratio. There always has to be an angle there, the one you know, or the variable for the unknown angle. Okay? And then this side is always going to be a ratio. Right? The division of the opposite in this case as compared to the hypotenuse. So if I'm using this angle, the sine ratio in this triangle, the sine of angle A, is defined as the opposite side as compared to the hypotenuse. So if this was 7 and this was 12, my sine ratio of angle A would be 7 over 12, or BC as compared to BA. The cosine ratio is defined as the length of the side adjacent. Remember, the adjacent side is always next to the angle but not the hypotenuse. So the adjacent as compared to the hypotenuse is defined as the cosine ratio. And we, a lot of times, instead of writing sine, we would just write S-I-N, but we'd still say sine. I would say this is sine A. Okay, so we never say sin. We always just say sine A. There's no shortcut for sine. You still always say sine. However, for cosine, we can write C-O-S instead of all of the word. And this one, there is a shortcut. We can say the cos of A, cos A. So just be careful. A lot of people always like to say sin A, but it's still, you would say sine A, cos A. And of course, the shortcut for tangent is tan A. It means the tangent of an angle, cosine of an angle, sine of an angle. And a nice little way to remember this, little memory tool to remember that the three ratios, right? The sine of an angle is equal to the side opposite as compared to hypotenuse, is the SOH. The cos of an angle is equal to the side adjacent as compared to the hypotenuse. You can see that the cos is adjacent as compared to hypotenuse. And the tan of an angle is the opposite as compared to adjacent. And so that would be that portion. So some people remember the acronym or the word SOHCAHTOA. SOHCAHTOA. So that helps us remember the three ratios. I will allow you to bring in the ratios in a formula sheet, so you don't really need this. It just speeds up the process, and it's handy to have in your memory bank. Or some people write SOHCAHTOA like that to help you remember that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. All right? So, oh, I forgot to fill this in. The sine of angle A is opposite or BC as compared to AB. The cos of angle A is the adjacent, which is AC, as compared to AB. Right, we can fill that in. All right, so here, what is the sine of angle E? The sine of angle E would be opposite FG as compared to hypotenuse, EG. Okay, or the sine of G would be, if I was asked for the sine of G, it would be, whoops, I don't want to erase the actual triangle. It would be the opposite, which would be EF, as compared to hypotenuse, which would be EG. Okay, a little note with the sine ratio. EG is the hypotenuse. The hypotenuse of a triangle is always the longest side of a triangle. Okay, so the two sides, EF and FG, these two sides, are never going to be greater than the hypotenuse, right? So if the hypotenuse is in the denominator, and the denominator is always bigger than the numerator, we know that the sine ratio, the sine of an angle, is always a ratio less than 1. It has to be a ratio less than 1. because our hypotenuse is always the longest side, and these two sides are always less than, never negative either, right? Because these are actual lengths. So it is always going to be a number that is greater than 0, but less than 1. Okay? Can't even equal 1 because EF could never be the same as the hypotenuse, right? It has to be less than 1. So if I said, what is the sine of 75? Again, you should be able to type that into your calculator. And the calculator knows that the sine of 75 is 0. And I'm going to write out 4 decimal places. Okay, and if I had to draw a diagram to explain what this ratio means, I would draw a right triangle because SOHCAHTOA, sine, cos, tan, only applies to right triangles. And I would put the 75 degrees in one of my 2 acute triangles, doesn't matter which one. And then this ratio is a comparison, opposite as compared to hypotenuse. So I'd have to create the denominator over 1. So the opposite to this angle is 0.9659, and the hypotenuse is 1. You can see they're very close in length. This length is just slightly smaller than that, based on the ratio. Okay? Again, if I give you the ratio, you should always be able to find the angle, right? So whenever you want to find an angle, you solve for the angle, and you solve for the angle by undoing sine. How do you undo sine? You do the sine inverse of both sides. So that means that taking the sine inverse of sine cancels it out, and taking the sine inverse of 0.5, well, we need our calculator. Sine inverse of 0.5 is 30. So now I know my angle is 30 degrees. Same thing here. If I want to ever find an angle, I need the inverse of the ratio to find the angle. If it's a fraction, you just keep it as a fraction, and when you type it in, you take the inverse of cos, bracket 8 divided by 12, close bracket, and then you can get, if I want to round it to the nearest degree, I would get 48 degrees. So if you know the ratio, you should be able to find the angle. Okay? So, how do you know which ratio to use when you're finding an angle? How do you know if it's sine, cos, or tan? So if we wanted to find angle H here, how do we know if we're finding sine, cos, or using sine, cos, or tan? Well, you have to always name the sides based on the unknown angle. So I have to say, if this is H, the angle, across from H is opposite, next to it is adjacent, and of course we have our hypotenuse. So we first name our sides. Then we choose the 2 sides that we know. I know that we have the hypotenuse is 7 and the opposite is 3. Based on the 2 sides we know, we choose our sine, cos, or tan. Which one uses opposite and hypotenuse? Oh, that's sine. So we now know we're using the sine of angle H is equal to 3 over 7. So you first have to name all 3 sides, or at least name the 2 sides you know. You don't even really have to name this side because you don't know it. So name the 2 sides you know, and then pick the appropriate ratio. So now I would say, well, angle H is equal to sine inverse of 3 over 7, and then again we go to our calculator, and we would type that in, and we would be getting 25 degrees, round to the nearest degree. Okay, same thing here. So if this is the x, the angle I want to find, this is the hypotenuse, and this is the adjacent, right? Those are the 2 sides we know, so I'm going to name those 2 sides. So I'm going to use cos, because that uses adjacent and hypotenuse. The cos of x is 10 over 11. X is cos inverse of 10 over 11. I'm going to type that in, cos inverse, bracket 10 divided by 11, and I get 24.6, or I can round it off to 25 degrees approximately. So that's how you find the unknown angle. Same thing with finding the missing sides. You have to name the sides you know and the one you're trying to find. So if this is 51 degrees, I know that this is adjacent, and this is hypotenuse. By naming the two sides, the one you know and the one you're trying to find, you now know which ratio to use. Oh, that's cos. This time I know my angle, so the cos of 51 equals adjacent over hypotenuse. Solving algebraically, multiply both sides by 95. 95 cos 51 equals x. And again, you type this in your calculator. When you're finding a side and you know the angle, you don't use cos inverse, right? You just undo what's happening to x. So 95 cos 51 is 59.8 to the nearest tenth of a degree. So I would get 59.8 meters is equal to x. That's the height of that triangle. I call this the vertical height. I call this the horizontal distance. And I call this the length of the diagonal, right? So if this was an airplane in the air, this would be the altitude. This would be the horizontal distance to the runway. And this would be how far it has to travel on the way down to the runway. Okay? So over here, this is my angle. So this side I'm trying to find is opposite. This is hypotenuse, so that's going to be sine. The sine of 39 is equal to opposite over hypotenuse. And again, x is on the top, so I multiply both sides by 400. And I type that into my calculator. And I get 251.7 approximately meters for x. Okay, let's jump down to a couple more. Let's do this one. If I want to find AB, I better put an x there. Now I'm going to name. This is opposite. This is adjacent. So now I'm using opposite and adjacent. That's the tangent ratio. So I would go the tan of 30 equals opposite over adjacent. And since x is on the bottom, I have to multiply both sides by x. So x tan 30 equals 5. Now divide both sides by tan 30. And then I would type that into my calculator, 5 divided by tan 30, and you would get that. The length of x is 8.7. All right? And again, here, if we want to find AB, that's now our hypotenuse. So this is, we'll label hypotenuse. This is adjacent to this angle, right? We don't know opposite, so we don't want that. This would be cos. Cos 40 is adjacent over hypotenuse. X is on the bottom, so we multiply both sides by x. Divide both sides by cos 40. And now we pick up our calculator once we're done writing out all the algebraic steps. And we type in cos 40, 6 divided by cos 40, and we should get x to be 7.8 units long. All right, so that's finding a side, that's finding an angle, nothing new except we had to know how to label it in order to know if we're using cos, sine, or tangent. Again, a reminder, make sure you know the difference in this question. If I ask you what is sine theta, I'm asking for a ratio. If I ask you for theta, I am asking you for an angle. So in this question, sine theta is your opposite as compared to hypotenuse. The answer to A, sine theta, is 3 over 5. Stop. You could change that to a decimal by going 3 divided by 5, or you can just leave it as a fraction. This is a ratio, a comparison of two sides. B asks me for theta. Well, now you have to use the ratio to find the angle. I know the ratio is 3 over 5, so to find an angle, you do the inverse of the ratio. So I'm going to go shift sine bracket 3 divided by 5. I get an angle to be 37 degrees approximately. All right? You should be able to draw a diagram, label it, and then be able to solve. So the length, we want to find the length of a kite string if the kite is flying at a vertical height of 43.3 meters. I always like to have my ground for a reference. Okay, here's my kite that's in the air. Whoops, that's a terrible kite, but we get the idea. Holy smokes, this is a very terrible kite. There we go. So we have our kite flying in the air. We know it is at a height of So vertical height, so that's vertical to the ground, perpendicular, right? That's 43.3 meters. That's the height of the kite. We want to find the length of the string. Well, the string is there, right? So that's the length. And we know the string is making an angle of 62 degrees with the ground. So I know that the 62 degrees goes in there. So I've labeled what I know, and I've labeled what I'm trying to find with a variable. Now I can go ahead and figure this out. This is opposite to the angle I know, and this is the hypotenuse. Therefore, I'm using the sine ratio. So the sine of 62 degrees is equal to the opposite side as compared to the hypotenuse. And now I can solve it by multiplying both sides by x. And then dividing by sine 62. And then I pick up my calculator and I type that in. Oops, I typed in an extra button, and there we go. So we now know that the length of the string is approximately 49 meters long. That's how long of a string that is there, based on those measurements. All right.